Bismillah, alhamdulillah, salatu wassalam ala rasulillah. It's a great pleasure to be here. Many thanks to the organizers and all the volunteers. May Allah bless this community. So my talk today will be an attempt to share some examples of the engagement of the Muslims in the past with the skies, whether as a community or as a study, as an astronomy. And I'm going to spend some time looking at past examples. I'm going to spend some time looking at examples from the past and then try to reflect those to our current time and inshallah to the future as well. Trying to provide some examples of engagements at different levels and different interests. So how about we start with a story? Many, many years ago, I was an undergrad student traveling from Syria towards the region of Mecca. It was late at night, we were on the road, and I think I was around the Tabuk area, which I can't exactly see in this resolution, but it was really dark. I had a flashlight and a book, and I thought I'm gonna just spend the night reading. At some point, I turned off this flashlight and I looked outside the window, and I didn't expect that I'm gonna see something that looks like this. This is an actual image from the desert, somewhere in Saudi, I'm not sure where. Now, at that time, I was a physics student, and I was into astronomy. I've seen many images of the Milky Way, and I lived in a relatively large city in Syria. I did not expect that reality as a person, you can actually see those images if you're in a dark spot. Now, till this moment, I still cherish the moment when I had that view. I was completely absorbed, just looking in, face to face, being in direct contact with this beautiful stream of silver, golden light running across the sky. SubhanAllah. Now, a quick crash course for those who don't know. One slide, astronomy course of the galaxy. In astronomy, the Milky Way is just called the galaxy with a capital G. It's this stream of light. It's a disk galaxy with spiral arms. And we're located somewhere here. My hand's shaking, you can probably tell. The solar system is located at a distance of about 25,000 light years. Now, this funny sounding unit of light years is the distance that light covers when it travels. And light is the fastest that is. So if light takes about 25,000 years to reach us from the Milky Way, this means we're looking at way before we were born. When this light was produced. This region here is the center of the galaxy. It's called the bulge, and it includes a supermassive black hole of a mass of 4.5 almost million times the mass of the sun. It's dormant, so it's not really doing much. But in most galaxies like ours, large galaxies, supermassive black holes are active, and they outshine the entire galaxy. In this case, we call them quasars. This is what I studied for my master's and PhD. What else to say about the Milky Way? So, in a way, when we talk about the light coming from the universe, astronomers, in a way, they study the history of the universe. We study the universe the way it used to be when that light was emitted. And I try to to draw parallels from this when I look at the history of science. I enjoy studying the history of science. I'm not a historian, I'm a scientist. But when I study the history of science in general, and Muslim scientists as well, I feel like I gain a different perspective. I gain more appreciation of how science developed and what these formulae we write easily and we calculate and stuff, how they came to be. And that's a whole different level. This is the view that our ancestors used to enjoy. That was what they saw in the sky when they looked at night. Now, let's do a little activity by show of hands. How many of you had ever had the chance to see the Milky Way in this level of light? I know one of the volunteers yesterday told me that the Imam, I think, took them to a camping trip in Utah, or someone from the community, maybe not the Imam, and they actually got to see the Milky Way. But how many people here actually were able to see the Milky Way in a similar fashion? Okay. So I wasn't really expecting many, and I'll tell you why. So a recent study from 2016 surveyed the light pollution in different areas on the planet. And this is how North America looks like. Really kind of depressing numbers. More than 80% of the world population, I can't read from here, 99% of the US and Europeans, basically high numbers, can never see the sky at night, can never see the Milky Way. They don't have access to it because of how much light is emitted towards the sky that outshines the faint light from the stars and from the Milky Way. So it's normal for people who live in a city like Memphis not to be able to see anything. Last night when I arrived on the way, I was able to see the moon. There was some thin clouds. I tried to see if I can spot any star. I wasn't able to, maybe because of the cloud, but I wasn't able to see anything. So you can probably see from this image, the red spots and the yellow spots are where there's very high light pollution. This is a map of the world, which also shows the same results. North America and Europe mostly light polluted. I can tell you that this study was updated in 2023. I quickly looked through the results. The only thing I can tell you is that things are getting worse. That's the main conclusion from the study. So this is the sky our ancestors has access to. When I say ancestors, it doesn't matter where your family, where your ancestors come from, not necessarily only in Arabia. Peoples all over the planet had access to the sky, whether they're from Africa, North America, South America, India, Arabia. They were able to look at the sky every night. They told stories about what they saw. They recognized, most importantly, the pattern, the repeated pattern, which it was connected to the time, the dates, the seasons, the weather. So they recognized that this is vital for their livelihood. Their calendars were based on what they observed in the sky, their directions when they traveled, the seasons, the rain, a lot of the important factors that allowed them to survive were connected to what they saw in the sky. So I've looked at some examples from Africa and some examples from the indigenous communities here in North America. And there are differences in that, how they tell the stories, how they tell the tales of what these different configurations in the sky mean, the constellations. But they all share this common theme of trying to create stories around what they see, not necessarily because they have an intrinsic meaning, but because it was their way of conserving their knowledge around when the stars rise and when they fall and what that represented in terms of life. And I'll show some examples. So here's one example from Arabia that I like. Al-Thuraya, very well known mark in the sky. It's an open cluster that includes young stars. That's why they look blue. Young stars are bluer than older stars. You can see them here. This is Taurus, and this is Al-Thuraya, the Pleiades, as the Greeks call it, and now we call it the Pleiades. Al-Thuraya was very well known for Arabs in Arabia. They called it Al-Najm, basically, the star. And some commentators say Surah Al-Najm is referring to Al-Thuraya. Now, you can see here there's another star called Aldebaran, which is a red giant star. It's very visible in the sky if you know where to spot it. Reddish and really large. It's a red giant, the way astronomers usually classify stars. Now, when Arabs told the stories of what happened in this configuration, they had different names for the constellations. They didn't call them the same way we call them, or the Greeks used to call them. So they named them differently, but they also still told tales about them. A story I like about the Thuraya is that Aldebaran wanted to marry Thuraya, but she asked for a really large mahr. He was poor, and then he collected the mahr she wanted, the cattle, and then he presented it to her, but she still refused him. And that's why when they rotate in the sky, Arabs used to think that Thuraya is running from him and he's following her forever, locked in this cycle. And then poets will write about it. So here, a famous poet, the Rumma, said, so I can't translate this, obviously, this is old poetry. But what he's saying is that he was traveling. When he reached, it was around the time when Thuraya was flying up in the sky, followed by Aldebaran. And they're gonna be, forever locked in this state where she can't escape him and he can't reach her. So kind of like telling the story. Another poet, Tufail, is referring to Aldebaran as, a very faithful one. So it became a reference for someone who's really faithful and they keep their promise. That's how they conserved their knowledge about the sky. This wasn't, you're probably wondering why she's telling us those stories, because we're gonna see very soon why this was vital, why this was important, and how, most importantly, this actually contributed to science and to astronomy. We'll see in a bit. This is another example for the Big Dipper, as the Greeks call it. Arabs used to call it Banat Nash, assuming that this square here is a coffin, and those three daughters are following the coffin of their dad, forever also locked in a cycle, trying to take revenge from Al-Jadi, who assassinated him, who killed him. Allah subhanahu wa ta'ala says in the Quran, وَعَلَامَاتٍ وَبِالنَّجْمِ هُمْ يَهْتَدُونَ. And there are numerous ayat in the Quran that describe Allah subhanahu wa ta'ala's ni'mah in terms of creating the sky in the way he did. A famous jurist and historian, Ibn Qutayba, from the 9th century, wrote a book where it's called Al-Anwa' 'Inda al-Arab. So basically documenting the different seasons that Arab used to have. And then in one of the quotes that's very interesting, it's very long, and this is my translation, so pardon me if it's a little rough. He says he was traveling once with a Bedouin in the desert, and Ibn Qutayba started asking the Bedouin about different tribes and their water, and kind of like trying to get information about the area. And that Bedouin, every time, will answer him by referring to a star, either by pointing directly at it, or naming it, or telling him, if you follow a certain star, you'll find those people. And Ibn Qutayba realized that this is how the people at the time found their way around, basically as if you're in a city and you know that's the path to reach a certain destination. That's how familiar they were with the sky. He goes on, actually the quote's a little long, he goes on to say that this doesn't just apply for finding locations, but also for things like related to the weather, which was very important for them to know when the rain will fall and maybe there's a flood to avoid, or if to move to a certain area or not. And then a Sufi who was Abdurrahman Sufi, very famous 10th century astronomer, he did a very important work. So many people know that stars have Arabic names. It's true, many stars in the sky. When I was taking astronomy courses, one of the courses was basically an intro-level course where you just take a small telescope and go to the observatory and find a list of objects, stars and other things. It was very evident that I was able to recognize many, many star names. People trace that back predominantly to Abdurrahman Sufi's catalog of stars. He took the ones from Ptolemy, and then he reviewed the ones that the Arab used to use, and then he converted those, he referred to them, he cataloged them. So when the translation was happening from the Arabic books to Latin, they found the Arabic names easier because they're only like one word, instead of the Greeks, it was probably usually longer. So they kept those. Latinizing some of them sometimes became hard to recognize, but this is how most of the Arabic stars' names ended up being kept until the modern day. Very interesting things about the Sufi as well is he was probably one of the first people to document seeing the Andromeda galaxy. Obviously the Andromeda galaxy, when you look at it in the sky, you see a patch, you probably can't tell what that is. He documented its existence and put it in his tables and called it Latha Sahabiya, basically, as you can see here if you read Arabic. Latha Sahabiya just means that, a cloudy patch. And this continued to exist when the tables were translated until it was recognized as a galaxy. This is a beautiful image of the Andromeda galaxy from the Moroccan desert. So for those who don't know, the Andromeda galaxy is the closest large galaxy to our own Milky Way. It's a spiral galaxy, spiral disk galaxy, and it's quite large in the night sky. It's very faint. Supposedly, if you're in a dark spot, you should be able to see it if you know where to look. I tried myself. It's actually challenging, and mostly you're probably going to be able to see the core. You probably won't see. This is a long exposure image, obviously, but you might be able to see the core if you're in a really dark location. So when Islam started to spread across the land, Muslims started seeing more challenges related to applications in Islam. So how did this manifest was in different areas. One was the Qibla direction. So if you're in Mecca, it's obvious. If you're in Medina, the Prophet ﷺ told them just pray south, also obvious. But when you start moving to Baghdad or Cairo or even North Africa, far away in Morocco or Andalus, how do you find the Qibla? It's actually challenging. And this figure here from a famous historian of astronomy, David King, shows how this wasn't a simple answer. Different cities have different directions for the Qibla. In one way, different madhahib have different tolerance towards how precise the Qibla direction should be, which is a religious decision. But at the same time, astronomers developed tools that allows you to be able to look, to calculate a more precise direction for the Qibla. But those methods weren't always accessible for religious authority. And this created a really rich discussions around who gets to be the mujtahid here, who gets to decide. Is it the astronomer who has all the nice gadgets and they can use them in the tables and look up things and calculate the directions? Or is it the jurists who know the hadith and they trust the texts they have? And in some cases, some of those qiblas were determined by Sahaba who decided to that this is the qibla for this masjid. So how would you change something like this? And it's a really tough decision. Not necessarily one of them is the right or wrong, but it's the discussions around who gets to decide were really interesting discussions to follow. And those kind of decisions became more and more with the time when, in one way, the tools that astronomers use became more accessible. And the teaching of such knowledge became, was introduced in madrasa systems curriculum in the 13th century, where more people started making those decisions from within their religious organization. The same thing applies for calendar determination of the start of the lunar months, where they used the distance between the moon and the sun. They created tables. Different cities have different timings for stuff like that. So astronomers felt that they're qualified to make those decisions, while religious authorities thought, we should use classic methods. They had the very similar discussions, but they're also a little different, that the discussions we have right now around moon sighting. I don't necessarily find anything wrong with those discussions. They're a good opportunity for both sides to learn from each other and to educate the community around issues related to astronomy and to their religion. The same thing was also for miqat. Prayer times was also done. Tables existed. Astronomers were able to develop approaches and instruments to do those calculations, but they weren't easy to use for the mu'adhins and the masjid. And then until the timekeeping institutes were introduced, the muaqqit books and training, that this became a religious decision. So the mathematical and observational astronomy aspect, I know Dr. Noor yesterday talked about this, so hopefully I won't go much into it. I just want to mention a few examples just to keep the idea that we're trying to scan for examples that give us a sense of how the Muslim community in the past engaged with the skies, whether on a cultural, folk level, or religious level, where there is an application directly related to religion, or on the more scientific, mathematical method, where it didn't necessarily have much application in people's lives. So the Almagest was the main reference at that time for astronomy. It was what people relied on, not necessarily because it was complete. It actually had many inconsistencies, but it was the reference that they had, and it was predominantly important for anything you want to do. And it was translated into Arabic, but it was criticized. It relied heavily on Aristotelian cosmology, which caused those inconsistencies. Ibn al-Haytham, many people criticized it. Most famously, Ibn al-Haytham, who's known for his work in optics, but he also started what's been later on referred to as a shukuk tradition, the doubts, basically, doubts on Batlimos, al-shukuk ala Batlimos, or on doubts on Ptolemy. So basically criticizing from a philosophical point of view, and from, most importantly, physical point of view, the conclusions and the models that Ptolemy put in his book. Also another very famous giant in the fields of geography and astronomy and many other fields was Al-Biruni, who also criticized those models. And what was really interesting is that they relied heavily on the physics of how this can manifest and how this can be inconsistent from a very scientific perspective, not necessarily focusing much on the philosophy. George Saliba, who's a famous historian of astronomy, he has many interesting books and articles. I enjoy reading and learning from him. One of the quotes I find interesting when he says Islamic theoretical astronomy was a continuous debate with Aristotelian astronomy, but was guided by real sense of commitment to the physical universe, of which those astronomers attempted to make some sense. So they didn't necessarily wanted to break out of that paradigm. That wasn't their intention. They wanted to continue with that cosmology, but they didn't mind criticizing it when they needed to. And this happened very, very often. So there are so many characters I want to talk about, but there isn't enough time, and I think it won't be as useful if I just crammed so much information in this presentation. I just want to focus on one figure, and I'll mention why. Ibn al-Shatir of Damascus is one figure that's interesting, and I think is worth highlighting his contributions. For one, he was a muwaqqit. He was a timekeeper at the Umayyad Masjid in Damascus. So he had the role of calculating prayer times, a very specific religious role that he kept at the Umayyad Masjid. But through this role, he was also an inventor. He built this many tools, including a sundial that was attached to the Minara at the Umayyad Masjid. I think now there's a replica for it. I'm not sure if it's still there. He did diligent observations. He revised the Ptolemaic models. He continued the constructive criticism by providing his doubts on certain areas and alternative models. I also really like that his models used some of the work that was done by well-known astronomers before him. Those are the people I really wanted to talk about, but I don't think we have time, like Al-Urdi and At-Tusi, who were members of the Maraga Observatory, which was mostly like a research institute for the most advanced research in astronomy. So he incorporated that research, those results in his models. His models were shown, I think it was in the 1950s, to be very similar to those that Copernicus used. And maybe that was discussed yesterday. It was found that a lot of the models that Copernicus relied on and used in his results were actually very similar to what Ibn al-Shatir produced. So I think if we want to look at Ibn al-Shatir, what I really like and wanted to highlight here today is that as a scientist myself who's done research, I find there's a lot of similarities between what a scientist will do on a daily basis and what this activity here listed shows. Adding to this, that he was functioning within a religious institute. So he was a muwaqqit at the masjid, but he was an inventor. He collected data. He created models. He did, literature review, I guess. He used models from people before him. And he provided solutions for the existing inconsistencies that existed in his time. So really worth studying. He was also 14th century astronomers. This is important. There are people who came after him, but this is important if you also look at the ideas of decline, supposedly, that happened after whatever 12th, I think, century, they usually say, to show you that actually for astronomy, this was the exact opposite. It's probably peaked after that supposed decline. Let's talk about today. So I wanted to spend some time at the end to talk about astronomy today. Some of you might recognize this famous image from the James Webb Telescope. This is a deep field image. To my knowledge, this image includes 7,000 galaxies. And to give you a sense of how awesome this is, if you get a grain of sand and put it on your finger and stretch it, that's the size of this image you see in here. And that's how many galaxies were observed in this image. We're really privileged to live at a time where there is so many advancement in technology and science that allow us to literally just punch some numbers and things on your keyboard and be able to study things like that, build instruments, send it into space. This is wonderful things that we shouldn't be skeptical about. I know many people will be skeptical sometimes about science and technology and how their impact on our lives, but I think we can always construct these things in a way that benefit us and allow us to be better people and better citizens of this planet, and hopefully also better Muslims. So let's give some examples of engagements that Muslims can pursue now in the 21st century in North America. People from different walks of life, different levels of interest in physics and math, or maybe none. I collected some examples, but I'm sure there are others, and feel free to share any if something comes up. The most traditional one is, physics, astronomy, astrophysics, degrees that you can pursue at the university, a research institution, whether as an undergrad or a grad student. You can study the physics. I took some screenshots from my PhD thesis. I was just trying to search for something that looks sciencey and physicsy. This is basically atoms, different levels of energy, and shows supposedly some ionization. These are the spectra I spent years and years studying. They show signatures of, we call it wind or emission, absorption in quasars and the surrounding region, and some calculations related to the black holes that create that activity. So some people will study planetary science, some people will study engineering, and go on to work in NASA or build rocket ships and stuff like that. So all those fields can lead to more and more knowledge related to astronomy and space. Another venue that I really like, and I hope more people will pursue, are things related to philosophy and theology. People who might not necessarily be interested in physics and math can pursue areas where you can study these things to prove the existence of God, or to understand how science works, especially at the time where science is unfortunately used to discredit religion. These areas of these topics regarding the expansion of the universe, what's dark matter, the mysteries that science don't understand, provide a lot of room for understanding what science means and how that relates to our religion. Very interestingly, a few months ago, I was watching an interview with a very notorious anti-religion scientist. He's into science, what's called scientism, which is a mindset that tries to discredit the existence of God using science. So it's even a little step further from just simple atheism. They use science to say there's no God, and that science and religion cannot exist. And what was really interesting, the interviewer was a Christian, and he was, they reached a point where they were talking about fine-tuning and how the certain constants that exist in the universe, that allows the universe to exist, cannot be coincidence. And that scientist, who I'm not gonna name, he said if there's anything that's gonna convince him of the existence of God, it will be this specific argument, that very hard for him to, digest, that there's this sense of fine-tuning that he sense exists, but he's still struggling to make sense of. So this is really interesting area to explore. Another one that I really enjoy, and I was happy to see even participants in our conference today, they were just chatting with me, is astrophotography. I know these are photos. I added the reference for the brother who sent me those images. I'm in touch with some of them in Canada, where I live. They engage with the community through many activities, including astrophotography, where they just go out, they take beautiful images of the sky. It's a really interesting field for those who like to get small telescope and camera, and then they kind of work with those tools. Here is another set of photos from a different amateur astronomer and astrophotographer, Muhammad. Previous ones by Brother Amir, also both located in southern Ontario. The Milky Way, you can recognize it here. The Pleiades, which I just showed. Here's the Hilal as well. I'm not sure if it's visible for you on the screen, but there's a Hilal there. Both brothers participate in public outreach. And I want to highlight two examples here that are very important, and they're very close to my heart, because the two brothers bring their astronomy to the Muslim community. Here are some photos of Brother Muhammad, who works in building aircrafts, going to the masjid, taking his telescope and showing the kids and everybody at the masjid, talking to them about astronomy, showing them some objects in the sky, and creating some excitement about the topic, which I think is something we should all encourage and go talk to our masajid about. And as I said, somebody told me here that the masjid here organize like a camping trip. But this is really important to go to dark locations and talk to people about the sky and look at the stars and have some sort of discussions around those areas. Brother Amir also, who works in marketing, organizes a group of Muslims who live in, I think around the Toronto area, where they go out to look for the Hilal, and he created this information sheet where to make it more accessible for people to understand what does moon sighting mean, and looking through his tools. And I forgot to mention as well that Brother Muhammad, I think, is really active with the Royal Astronomical Society. So there are local clubs where people can participate. The last time I checked with them, they were, maybe I shouldn't be telling, but they were actually planning on creating a network for Muslim amateur astronomers in Canada, maybe in North America. So if you're interested, you can reach out to them and keep an eye. Maybe you can join the network as well. For those also who are into advocacy or journalism or any sort of public interest, they can also look into the topic of advocating for the environmental impacts of polluting the sky with extra light and with those low orbit satellites. This is an image for, I think, SpaceX constellation, I think they call them. Nothing wrong with the technology that brings the internet or any advancement to people. But it's important to notice that this is polluting images taken from a telescope that was supposed to be doing astronomy research. Not to mention also the light pollution that's preventing us from seeing the sky that humans, for vast majority of their history, were able to just look up and see these things. It's part of our DNA to be able to look at the sky and see things. And we're really deprived of that nowadays when we live in cities where you really can't see anything. There are simple ways to fix that, and I hope some of our youth will reach out to our Islamic centers and masajid, our cities and MPs, and talk to them about policies to reduce light pollution in our cities. So to allow us to see these beautiful features of the sky and connect with our environment. Not also to mention the harmful impact on the species that needs the darkness, need to be impacted by the sky. And what some research mentioned is this extra light is impacting our sleep pattern and our health. I'm going to leave you with this quote from Al-Urdi, Mu'ayyaddin Al-Urdi, who was, as I mentioned, a member of the Moraga Institute. He was an engineer. He was known for building really smart instruments. And I love this quote because it captures the spirit that I like about Muslim astronomers. They didn't necessarily see conflict between Islam and religion. They were able to function within the harmony of being a Muslim and being a scientist. They actually got inspiration from their deen to pursue their profession and be the excellent astronomers they were, inspired by their religion. I won't read it this long. Take your time reading it. I know I'm out of time. Yeah, so I'm done. Thank you, Jazakumullah khair.